Hi everyone, it's Jason from CS Academy Coimbatore, and today the experiment we'll be looking at is the charge meter. So we're going to be designing an hypothesis, and also we're going to be looking at the problem demonstration. Alright, so first up I have points written down here, and then we're going to be looking at like the hypothesis. So yeah, our main task here is to make our device as accurate as possible. We're going to have two charged plates, and then we're going to have a charged ball in between those plates, and then this charged ball is going to be deflected at an angle. It's going to get attracted to one of those plates. It'll be deflected at an angle, and we're going to use that angle to measure the charge in the ball. So that's our aim here. Alright, so our hypothesis is going to be we're going to make sure that in order to make the device as accurate as possible, we're going to eliminate all the external factors. We'll discuss about it later. So yeah. And then first of all, let's look at how we're gonna do our problem. Before getting into the experiment, we have certain things we have to look after, which is basically the first thing is how are we gonna charge the styrofoam. There are different ways in which we can charge the styrofoam ball, which is basically conduction, induction, or by friction. And then also how are we gonna increase the charge in the ball to test our device. And also we're going to be looking at we are going to measure a charge, and we need to make sure that this charge matches the right amount of charge. So in order to do that, we're going to use a gold leaf electroscope, which basically measures the charge in an object. And also we're going to look at how we're going to create the electric field, the uniform electric field between those plates. As we know, E is equal to V by D, which is the formula, voltage by the separation of the plates. We won't be able to change the voltage. We're going to use a very high voltage. So here we're going to use like a small separation, so which will basically if D is made smaller, the size of the ball must be made smaller. How will you fix the entire system? That needs to be taken care of. And also the size of the foam ball and the amount of charge it's going to be storing, and then the surface charge density. Alright, so yeah, all this plays a vital role. Alright, so how are we going to do the experiment? So in order to do the experiment, we're going to take two copper plates, and we're going to pass a high potential, high voltage across them. So basically it's going to act like a capacitor, and then in between we're going to have a foam ball. We're going to charge a foam ball by either induction, conduction, or friction, and then we're going to hang it in between. So after this, what we're going to do is this ball is either, if it's positively charged, it's going to get attracted to the negative side of the plate, and if it's negatively charged, it's going to get attracted to the positive side of the plate. So yeah, and therefore we're going to measure the angle of deflection. In order to do this, in order to measure the angle of deflection, we need to make sure we're going to use, for example, we're going to use a protractor in this case. We need to make sure that our apparatus is as accurate as possible. And here we have, so the factors we're going to look after, like the external factors that's going to affect our experiment, is basically the air currents. So we're going to do this experiment in a remote location where there's no disturbance of air, but it's going to be very tricky to actually, but then we can probably implement the device in a vacuum or somewhere. And also we're going to look after the forces on the thread. If there is any tension in the thread, this will affect the experiment because it will affect the motion of the ball. If there's any air current, it's going to affect the motion of the ball, and also the sensitivity of our apparatus. Our main aim here is to make our device as accurate as possible, and therefore we're going to just make sure our apparatus are all as sensitive, so much sensitive. Alright, so yeah, with that we're going to be calculating the charge of the ball, and then in further rounds we're going to be discussing on how we're actually going to do this, how we're going to measure everything, and how are you going to determine the charge from the angle of deflection of the ball. Alright, so yeah, that's it for the problem demonstration and hypothesis. Thank you.